Welcome to a lesson with Dr. Powell. Let's take a first look at a theorem called the mean value theorem. Let's suppose we have a function f of x, which is this curved line, on an interval from a to b. I've drawn a straight line across right here. If we take the slope of that straight line, we think about the different points. This would be the point b, f of b. This point would be a, f of a. You take the rise between these 2 points, which would be f of b minus f of a, and divide by the run, b minus a. That would be the slope of this straight line. Now, what about the slope of tangent lines? We'd like to think that there exists some point on the interval such that the tangent line has a slope which is exactly parallel to, the slope which is equal to this line, so that the two lines would be parallel. The tangent line and the secant line should be parallel if their slopes are equal. So is there a particular point C such that is true? Let's look at the graph of the derivative function. Derivative starts up pretty positive and then it's going down to about 0. So it's something, so you have your derivative function and it's decreasing. We'd like to kind of think about if does it hit this particular thing. Now, looking at this, another way of thinking about this fraction is simply as the average value of f prime. How so? Well, let's look. Think about how we take the average value of a function of f prime. We do something like this, right? Well, then how do we evaluate this? We take the antiderivative of f, which is f, and we plug in b, and then we plug in a and subtract. Wait a minute. This is actually equal to the average value of the function f prime. Assuming that we can take the integral of f prime, which is based upon the assumption that f prime is continuous. And if f prime is continuous, furthermore, there's an intermediate value theorem that kind of plays out, which says it's actually going to hit right here in the middle. It's going to hit its average. So based upon that idea, there actually is a point C such that we are going to match up and meet. This idea is called the mean value theorem. And it works as long as the derivative itself is continuous. It has to be defined to be continuous on the open interval from a to b. That's all that's required. It just needs to be continuous on this open interval, so that if you and then of course its average is going to be between two different values, and so it's going to be able to hit its average. And that's enough. Also, can this integral even exist if f prime isn't quite continuous or doesn't exist at its ends? And the answer is, well, we can at least limit push to the ends, and when we do that, it's as if it's continuous, at least up to the ends, we can, this integral will work just fine. In fact, it'll be equal to the same thing because, I mean, what's the area of just a single spot? It's 0. So really, single spots don't really matter in this calculation. So we have the fact that all is required is that f prime exist and be continuous on the interval from a to b, and then it's going to be able to hit its average. In the next video, we'll state this theorem in yet another way. Thanks for watching.